Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And this is Shahriar from Bell Labs and the Signal Path.
Thank you very much, Shahriar, for joining us again. How
Of
long's it
course.
been? It's been a couple of years, hasn't it, since the 5G episode?
Yeah, we've done a few of these. I should start collecting royalties from the App
Right.
by now.
Trademark for
Yeah.
your face and name
Exactly.
appearing. Well, we do have a budget for this kind of thing, you know. So, yeah. How you doing, mate?
Good, good. Yeah, like I
Excellent.
said, we were saying, we spoke about 5G last time, and life's gone on with the pandemic. I'm sure a lot of people are now even listening to these things even more so. So I think it's good timing.
I suspect so, yeah. So what's been happening for you? You're still at Bell Labs, aren't you?
Yeah. Still at Bell Labs. I still lead the ASIC research team at Bell Labs and do the Signal Path, of course, as kind of a hobby here, part of my lab behind me.
Yep. So you still got time for doing the signal path? What's your frequency these days of content? Or is it just, it happens when it happens?
Yeah, it kind of happens when it happens. If I can do one, maybe two a month, I think I would consider that a success. Yeah.
Yep, because yours are very long form, detailed content as opposed to most other channels. I mean, what's your average video? 45 minutes, an hour?
Yeah,
Something
30 to
like
45 minutes, 70 to an hour. And I get a lot of complaints that I speak too fast. And I always have to tell them, look, an hour video, if I speak half that's 2 hours then, right? So you're going to have to slow down your side.
Exactly. Well, YouTube has the ability to speed up or slow down.
Yeah, exactly.
So, you know.
Yeah.
Yep. Nah, it's all good. All right. So we've covered 5G. That was a very popular episode. Not sure how many views it had, but I keep referencing it all the time for everyone who, you know, for the 5G, you know, conspiracy stuff, which keeps going around. And,
of course.
and just to debunk that, it is the go-to debunk link now.
That's
in terms of like, so it's really good. So should we talk about dodgy technology? Because you wanted to talk about misinformation. Not the medical as we're talking about, you know, as the as the hot
it's all the same
political topic. It's all the same. It's the same reasons, right? It's probably the same psychological reasons why people want to believe in various things. Is there anyone in particular you wanted to talk about?
Yeah, last time I think it was after we made the 5G. I made the 5G kind of amp hour episode with you. Then I made one specifically about is 5G dangerous. It was one of my episodes that I typically don't do that kind of video, but I thought it was necessary. And
it was.
The reaction was interesting. Obviously, the channel, the people who are watching it are almost all the time the people in the domain. They understand what is going on in the field. So that was an issue, but it also caught a lot of people who are not subscribed to the channel, who are not in our domain. I got death threats from that video.
Welcome to the club.
Yeah, obviously they're not serious. I'm sure. I hope they're not serious.
No, that's right.
But it goes back to the saying, and it's easier to fool someone than to convince them that they've been fooled. It's tough to change people's minds. Yeah, the reason I wanted to talk about this dodgy technology in general was because I was listening to somebody else talk about this, and I cannot unfortunately remember the name of the study, but they did this study on human interactions. So they made a very simple human model, and they connected the human model to other entities in their model, and they ran a simulation. So they ran a simulation such that every person is connected to 10 people, and then they ran that simulation. What happens to the progression of ideas that you agree with and ideas that you disagree with? And then what they did is that they increased the number of interconnects, meaning that more people are exposed to more other people's opinions. So intuitively, you would think that if you connect people to more people and expose them to more of the ideas, that it actually means that the good ones will kind of come to the top.
Float to the surface. Yeah, that's the
it was the opposite. Yeah, but it was the opposite.
It was opposite.
It was completely went the other way. And there are a lot of reasons for why that could be. One possible reason is that, let's say you talk with 10 people, and then you have 1 out of 10 people agree with you on some crazy conspiracy theory that you have. Well, then in your view, you got 1 person agreeing with you and 9 people disagreeing. So you may say, oh, maybe this is not the right idea. But when you go on the internet, and then you have 10,000 people agree with you, but then 90,000 people disagree, the problem is that it's still the same ratio.
Yeah, exactly.
But now you have 10,000 people agree with you, and then you're like even more convinced that that's the right idea. It's just a weird human trait.
Oh, wow. And I guess it depends on the source. It might depend on the source because, we shouldn't take authority,
of course.
There's no, as a reference, but humans can't help that. but then some people earn it, like yourself, for example. We know you're a 5G, one of the world's leading 5G researchers. So if you say something about 5G, we can be pretty sure it's not BS, right?
Sure.
We can be
from a technical view. Yeah, from a technical view, definitely. And then people always ask, you're not a doctor, you don't know the effect of 5G.
Right.
Of course, but as a scientist, I can interpret the work of other scientists that have gone through peer-reviewed work, right? So I can interpret them, understand them, and accept them that they have gone through the scientific rigor. And this doesn't mean it's the end of it. You continue to test, and I went through all of that in the video and so on. But then I saw a couple of videos you made. I think maybe your latest favorite topic is wireless power.
Wiggle, yes, who raised $5 million for an off-the-shelf demo of energy harvesting at 5 milliwatts or something.
Yeah,
it's just, come on.
Yeah, we had a phone call a while ago about the demo that, what was the company who had done the demo? You made a video about that too, about the phone wireless charging, remote charging, this big box in the living room.
Oh, yeah, that's right. Yes, and you helped. Yeah, we discussed that on the phone, and you helped out for that video. Yes. Oh, I can't remember the name. Xiaomi. I think it's something. Yeah, have to pronounce it. It's an XI something. It's Xiaomi wireless charger.
That's right. That's right. So and the question always comes. I think this is, and I know actually people who are fairly respected people in the millimeter wave wireless community who are working on wireless power transfer. The thing is that it's not that it's impossible. It's not impossible. It's definitely possible. It's just the issue is it a good idea or is it a practical idea? In some really niche situations, I think when you have maybe something really low power that's difficult to reach, or maybe for space in places where you want to have energy transfer between two entities in space, that might have some area. But for your cell phone on a day-to-day basis, is that really what you want?
I know, it's just, and there's so much practical. Just simply turning your phone from face on to this changes the entire capture area of the antenna, doesn't it?
So it changes everything.
How do we deal, we in the debunking community, I guess, in the scientific engineering educational space, convince people that something, yes, it works, but it's not practical, and that's the point. What do you think is the best way to convince people that, because that's the problem. All of these things I debunk work. In some, whether it's, you can get 5, tens of milliwatts out of this RF receiver, but it's never going to scale up to charge your phone at 5 or 10 watts. You'd have to pump 500 watts into it. You'd have to pump a kilowatt into it.
Everything we build is continuously moving towards more efficiency. Even if you look at just near field charging, as you know, the efficiency of a near field charging also drops dramatically when the coils are separated or misaligned.
Oh, yeah.
And that's one of the reasons, in the Apple phone, they have this now magnetic alignment procedures just so that they can squeeze out as much of this wireless charging, near field charging as much as possible. So when you now take this to longer distances, you have to sacrifice that efficiency for what is perceived to be convenience. But the issue of convenience only goes so far. Forget FCC regulations and the safety and the interference and putting all of that aside. Is that really the direction you want to go? Because these are massive engineering challenges.
Yes.
And if you get them to work, I'm sure you can. Is that really the right way? I'm not genuinely too worried about that even, because that's more, at the end of the day, the technology will either be adopted or not based on its practicality, regardless of what we think about it beforehand. It will either succeed or not.
Yes, that's right. So it'll either survive or die in the market.
Money will be wasted, all that energy will be wasted. That's a separate story. But the problem of the fake one is I think much more sinister and much more serious. I got this, one of the comments in the 5G video was this company, I forget now the name, that they're advertising these 5G protection things you can buy.
Oh, I've done a video on those, These little stick-on dots, and there's all different varieties. There's little, cubes you can just sit on your desk and it absorbs, or, it's got orgone crystals in it or rocks in it or something.
That's what it is.
Come on. Yeah. Come on.
I talked about this before too. I think, first of all, I'm sure the people who made those ones, I think they know they're lying. At least I hope. I
was going to ask that. Do you think that they know they're deliberately scamming people, or are they so hippie? Do they so believe it that they, Because I think there are people who fundamentally do believe that these things absorb and they just mentally, it doesn't matter how much technical information you throw at them, they just want to believe that this stuff works.
I think the ones who spin it on the kind of, I think it absorbs, makes me feel better. The ones who are spinning it by just hand waving it may believe it. But the ones who are spinning it as a, they say, here's a paper, here's a sign, I think they know they're lying.
Right, yes. I think you're right.
It's so obvious. I mean, all you need to do is to have very basic knowledge of electromagnetics. You don't even need to know anything in detail.
Yep.
But I may have mentioned this in the video, I forget now. But I was talking about how much the world has changed in the past, let's say 10 or 15 years. I was talking about the phone, just the iPhone. That I would argue that there isn't a single human being alive who understands everything about the iPhone from the end to end. Because there is, first, forget the ocean of software that's there. And then there is IC design, material design, and screens. And I mean,
it's incredible.
It just keeps going.
It
just keeps going.
Yeah.
And it's not the first time humans have created something that not a single human knows about that to end. But I would say it might be the first time where that thing is in everyone's pockets.
Yes.
And that's a unique situation.
True.
And the magic is almost gone. In a way, things that are just so sophisticated and they work so well, and people just take them for granted. I mean, what has gone into creating a phone? I mean, this is
it's incredible.
This is extraordinary.
Yeah.
And,
50 years of technological and software and all sorts of manufacturing technology progress, and it's just a nothing thing. It's just something that we toss away. It's just buy a new one.
And this is the part that's disappointing in a way. It's disappointing because I think as educators, it is actually kind of in a way our fault, right? Because we are the ambassadors of our own field, of our fields, and if we cannot demystify things while retaining the magic of it, then we are not doing something right. And then the disinformation will propagate and cause the problems that you see.
Is it destined to be not at some point? Any advanced technology? Oh, here we go. This is Isaac Asimov kind of, or in a reverse of Isaac Asimov, which was what any sufficiently advanced technology is indistinguishable from magic. Well, is any sufficiently advanced technology becomes just not magical anymore?
Well, at some point, it just becomes great. You take it for granted.
It becomes normal, right?
Yeah. So, and once you take it for granted, then you stop thinking about what has gone into it, and you stop thinking about the expertise that's gone into it. And if you abandon the expertise part of it, then you don't listen to the people who have actually created the technology, and it's just downhill from there. The other thing that is a major problem is that the amount of energy required to create a piece of misinformation is significantly less than the amount of energy required to fix it.
To debunk it or to change somebody's mind. Yes.
Yeah. Because it's so easy to say something wrong, and then if you really want to correct it, you're going to have to spend. And people just don't have the time. I mean, you can't expect every single person, and fear always stands out. Things that worry you always stands out, and you have to fight that. And this is depressing, to be honest, in some ways.
This is what we were talking about this, I think, briefly on email when you were talking about doing that video, the 5G safety thing, and I was saying, it's great because I was going to do. Did I do my own one? I don't know. I covered it somewhere, but I thought, to reach mainstream people, which are the people that matter, really, like not our audience. There's no point, our audience is going to understand, right? Because we've got a primarily technical audience. But to reach other people, it needs to be soundbitey. It needs to be TikTok. It need, the 1 minute TikTok thing. Debunk 5G in 1 minute. On TikTok, or it needs to be like 5 or 10 minutes because that's the usual human attention span for video type stuff. And we send out the link for the 5G amp hour episode where we totally, destroy the concept of, it actually being a problem from a safety point of view. But who's got an hour to listen to what is a technical type podcast? So how do we do that? Like, do we have to get on TikTok? Is that unfortunately, is that the...
Well, the problem is it's also genuinely difficult to get people to accept a piece of information because you can always accuse the person of either lying or not telling the truth. But it's funny how the things that make people feel like that someone's helping them to not be fooled. that stays with them much longer, right?
Yes.
So if somebody says, oh, 5G is doing this, or you're getting cancer from your Wi-Fi signal, or your brain is getting a tumor from your cell phone, all of those things are, if you get people, you tell them that, they're like, oh, of course, because corporations are evil, and a lot of them are, and pharmaceuticals are evil, and a lot of them are. And that the thing is, there is some truth to that, and there is just enough frequency of conspiracy theories to happen to be correct, just enough of it to constantly give them credibility, right? And anyway,
exactly.
It's a big problem.
Well, there's some people that you just won't convince. There's X amount, like I'll whack a number on it saying, 25% of the population, you're never going to convince, regardless of how much you try. It's like, it's, I could go into what's currently happening at the moment and stuff like that, but I won't. So, there is no matter what you do, it is pointless to try and even argue with them, or not argue, but try to explain things. No matter how TikToky you get, no matter how novel you get in your explanation, they're just going to go no.
Yeah. And so we talked about the 5G one last time we talked about, and I know at Bell Labs we now work on 6G, of course, because the 5G is considered mostly deployed. And from a technology point of view, obviously 5G promised so much that some of it is going to trickle down until it actually becomes reality. One of the big deals of 5G was this whole millimeter wave part of the ecosystem, and you bring this directed beam with a very high data rate. Now, one of the interesting things, these are public information and from white papers of various big companies like Nokia, Samsung and the likes, and Ericsson, they talk about this a lot. One of the things we're trying to do in 6G from a system point of view is that, so we've gone to these higher frequencies. There's potential of even going even higher than that. Some of the circuits we're working on right now are above 110 gigahertz. And
wow.
So these circuits, one thing that happens when you go to these very high frequencies is you go there just because you have a lot more bandwidth, right? The bandwidth translates to, of course, having the data throughput that you could potentially have. Now, this is going to be shorter distances, and putting that aside, one of the other things that happens is that radar also benefits from having more bandwidth, because with radar, the more bandwidth you have, the more resolution you have.
Right.
So the resolution of a radar is proportional to the occupied bandwidth. So this opens up this entire domain of creating radios that also are sensors, so that you can create a radio that's communicating while simultaneously imaging its environment in a radar fashion, piggybacking on the communication signal itself.
Wow. Okay.
Yeah, so you can do that at 2.4 gigahertz too, but the problem with doing it at 2.4 gigahertz is that you have a very narrow channel to yourself in the ISM band. So even if you were to want to use that channel for a radar application, your frequency is very low, your wavelength is big, and your bandwidth is very small, so your resolution is small. So it's not that useful. You could do it, but it's not that useful at lower frequencies. But then going to millimeter wave and then near terahertz, for communication also means why don't we create devices and sensors that do that too? And this is a stuff that people are talking about 6G potentially having sensing capabilities and applications built into it, which is an interesting domain of research too.
And that could also end up in phones and things like that. There could be some new novel thing that, your phone can scan your environment, for example. You could 3D map your environment with your phone using 110, gig or something like that. Is that the promise, I guess? Do you go in with applications in mind going, hey, this would be cool, and do you shape the technology to try and match the application, or do you just go, or do you just leave that to other people?
No, we do. We do take the application into account, because again, Nokia is a big entity, so they look at from cloud down to devices, right? So there's a lot of things in the middle, and the idea of your phone, modeling an environment. Indeed, you can already do that, because the cameras are so advanced. There's time of flight.
Oh, of course, you can optically do it.
Yep. But the thing about the RF is that RF, first of all, is quite a bit less invasive, because it's not a photorealistic image you're getting of your environment. But also RF kind of goes everywhere, so you can detect presence and movements without having the camera pointing at something. It's a different kind of sensing for other types of application is possible. So it's an interesting area of research that quite a few companies are looking at, and their publications, you can go and see people trying to piggyback on the 5G radio signals, things that can sense and model the environment. It's cool. It opens up, and that we take that kind of application space and bring it down, and we study what is the influence of those kind of applications at a circuit level. What do you want to do to your radio from a design point of view to make sure that it does those things well? Because a radio that does a radar circuit from an IC point of view and a 5G radio are not quite the same. There are differences between them. So you want to not do this dual purpose thing is not so straightforward in some situations.
Yep. Yeah, you might have to build in that capability, and then that might either double the cost, or it could, if you want to do that or something like that, that can have a product impact as well.
Yeah, exactly. Yeah, that's right. Yeah. And then this will eventually end up, some, Bell Labs is part of it is research, and some things may end up in the product, some things may not. Technology point of view, because we deal with semiconductors, there's also interesting things happening in that area around the world, because we have this, I think it was just a few days ago that the Intel CEO was talking about creating a new infrastructure of producing semiconductors at a larger scale. They have this 5-year plan to get to in the Angstrom level, which would be equivalent to a 2 nanometer kind of a FinFET device of some kind, potentially.
How do they do that? That's just like, that's, it's insane. How, because they're not doing that optically anymore, are they? It's just...
No, they're doing it optically. They're doing it, but they are. But as it's
there's got to be some other trick.
Yeah, there's of course there's God knows how many tricks.
I think there's a dozen tricks just to get where we are now, right?
And that's one of the reasons it's also become more and more expensive. There's this Moore's law thing that is kind of flattened out, and then there is the another equivalent of it that describes that the cost of semiconductors also goes up in the opposite direction. So what they do is once we hit this kind of FinFET nodes in the 16 nanometer CMOS nodes, and they become shrinking smaller and smaller, what starts happening around that area is, first of all, you went into this deep UV wavelengths. That's one way to get to the lithography you want. But then you can't do that anymore because the dimensions are very small. So what they do is that they do this thing called multiple patterning. So they take your layout, your semiconductor design, and they used to put it into a mask, create the mask at every different layer, and then illuminate the mask and then etch and do all the things. But now what they do is they break your design, the same layer, let's say on the same metal layer. They regulate the multiple. They pattern it in several ways. Now each of those patterns are larger because they're further apart. Yeah. And then they multiple pattern expose them on top of each other to get the fine resolution. So that increases. It's an absolute nightmare. But there's now restrictions too. So before, for example, this is now quite old now, but you used to be able to put your devices in any orientation you wanted. You could have the gates going in 0 degrees.
Okay. But now this is orientation dependent, really?
Yeah, but now you can't do that anymore because of the patterning limitations. Everything has to be the same direction. That's just one of the many, many things.
Wow.
Yeah. This is called the DRC rules. When you do this is also true for PCBs, right?
Yeah, exactly.
So the DRC stack, which is the complexity of how many things you have to take into. I mean, this thing is now massive. Of how many, and the tools are very expensive. You have to spend millions of dollars just for the tools. So the cost of development, and that's, if you look, there's actually, I think there's only maybe 2 or 3 semiconductor companies now in the world that can do these 5.3 kind of nanometer process in the TSMC. There's Samsung, Intel potentially could get there. And these are the guys who can do this extreme small lithography in the CMOS side of the devices, and which is the majority of the semiconductor manufacturing. And most of the stuff we make is actually not in CMOS. It's mostly in silicon germanium.
Got it. Is that silicon on Sapphire?
No, it's still a semiconductor. It's still pure silicon. It's just bipolar devices are silicon germanium based in the way they're made. And then there is also some CMOS in there. It's a hybrid technology. It's called a silicon germanium by CMOS process. But they put them all on the same wafer. But the CMOS is, of course, not nearly as advanced as the CMOS you use but it is kind of a helper device in a lot of ways. You can build, but the primary kind of star of the high-speed devices are silicon germanium. Now, silicon germanium is a device with a higher breakdown, so you can create high-power devices, and it's a different beast altogether.
Got it. So that's the kind of stuff you need for your RF transmitters and RF. If you want to do the energy harvesting thing, you've got to, how do you convert 10 watts of captured RF energy, right? That's extremely difficult.
Yeah, so it's an issue of linearity and so on. There's another class of semiconductor devices that are in CMOS. They're called SOI. These are silicon and insulator. So what they do is, normally in a traditional bulk CMOS process, the source and the drain of the transistor are in the substrate. They're all connected together in the same semiconductor material. What you can do is you can put them in these individual wells of silicon oxide. So each device becomes kind of floating. It means that the source and the drain are now isolated from the substrate. This has several interesting effects. One is that it reduces the parasitic capacitance and parasitics of the devices. But because it's now floating, it means that they can be at different potentials. So there's this whole other study of building power amplifiers that take SOI devices and stack them, and then they cleverly distribute the voltage.
To create massively higher voltage transistors when individually they couldn't.
Exactly. So you can get now a lot more power from devices where the individual device breakdown is below the power you're trying to generate, quite a bit below. And people have shown record performance in CMOS of these kind of things. This is quite an interesting area of, it's been going on for a while. It's not a new thing, but people are now pushing it further and further. It's been an interesting thing, particularly for 5G, because people have been building these millimeter wave millimeter wave amplifiers and phased arrays in those particular semiconductor technologies by these floating devices.
Right. Not only could you put them in series to increase the voltage, you could also parallel them, couldn't you, to increase the power capability? That's that's the advantage of that.
Of course. Yeah, I mean, the paralleling device is obviously very common. The issue is that, let's say you keep paralleling devices more and more, you're into a 50 ohm impedance, for example. At some point, the voltage swing across your 50 ohm load is larger than the breakdown of the devices. So there's only so much you can do before you reach that point where you can. You can't swing 10 volt on a process that has a breakdown of 1.2, right? So
exactly. That's right. It doesn't work. So you can series and parallel. You could have some big matrix of power transistors or something.
That's exactly how they're in fact built. And then there is the rise of gallium nitride, which I'm sure you've heard of. A lot of gallium nitride devices are now used in power supplies. You hear the kind of the
they even advertise it at the consumer level, don't they? They go, oh, this transistor has this uses transistors that have this X build technology, this actual technology, And there's actually been fake ones. Was it Big Clive or one of the other YouTubers? They took apart a fake one that was advertised as having this type of transistor in it, and they went, no, it didn't. It didn't. It was just, once again, dodgy technology, right? They're just marketing fake technology based on a kernel of truth, because it's always based on all these scams, whether they're scams or whether they're, just, airy-fairy, feel-good things, are all based on sometimes a kernel, usually a kernel of truth, especially the technical claims. They're based on, some technology, this audio cable sounds better because of skin effect on the cable, right? Skin effect is a real thing, but
but it has nothing to do with it sounding
better. Audio frequencies, right? Of course. It's just nuts.
I mean, there's also, to the people who listen to the audio things, to them it may sound better. It's a placebo, right?
It does. It's a placebo.
It works.
It works. I always say that.
Not for the reason they think. It's just not for the reason they think it works. No. But it does work. Exactly. It is also interesting that people talk about gallium nitride, because it used to be fairly obscure. Gallium nitride is an obscure technology. Now it's kind of found its way into the mainstream. It's kind of funny to see people who don't look at semiconductors talk about their power supply being gallium nitride based. It's
all the computer people. Thing. Oh yeah, my latest gaming PC's got gallium nitride power transistors.
Just in case people who are listening might be interested. So gallium nitride is a category of semiconductor devices with a very large band gap. So it allows the gallium nitride devices to have this huge breakdown voltages. Now, normally what happens is that when you increase the breakdown voltage of a transistor, you tend to make it slower. It's a very first order approximation. So, but with gallium nitride is that the advancement of that particular technology has created devices that are now fairly fast, but they retain this large band gap performance, very high breakdown. So what you can do is you can create switching power supplies, among many other things. But you can create switching power supplies where the transistors that switch the transformers have such a sharp rise and fall time, and such a huge breakdown. You can create extremely efficient DC-DC converters based on a gallium nitride device. That's why these power supplies are so tiny. They're like these super small power supply, and they give you 60 watts. It's because its own efficiency is so high.
Is so high, because then you don't have to, then there's no waste heat. The less waste heat, you're more efficient you get, the less waste heat in it. Therefore, the smaller and more compact you can make it, because you don't need large internal heat sinks or external, it just all flows on from there. So dodgy technology stuff. The problem I have is if people want to go is people who actually scam people out of money. Once money's involved, or health or safety or something like that, that's where I sort of step in. Otherwise it's like, I don't really, once people are harmed in some way, that's kind of my limit where I go, no, okay, I've got to do some, a video on this. So do you have a similar limit? Do you just not care about the small time stuff if it's not affecting people?
True.
Or?
No, I agree. I mean, this is the reason I did the 5G video in the first place, was because there were attacks on 5G engineers in the UK.
They were burning down towers,
towers.
Yeah, it's just
so again, it's a fear factor of it that is unfortunate. But and to be honest, in the medical industry, people who sell these oil things that cure cancer and all that, that's a whole other level of evil in my view. Because it's one thing to get $50 from somebody who thinks they're blocking 5G radiation, which doesn't do anything for them to begin with. But it's a whole other thing for them to think that they're getting their cancer removed.
Getting the cancer cured.
Yeah, which is a very different story. So definitely.
I get emails all the time, because I've been debunking stuff for like 12 years now or something. It was when first I did that. So I get tons of email on that. Can you debunk this or this and often it's a medical thing, because people want to believe that this thing's going to help them or whatever. And you can't blame them, because the slick marketing and everything else that goes along with these websites and things. And I can't debunk, I have to be honest, I can't debunk this. All I can do is laugh at it, because to debunk it requires proper scientific medical studies of people, your double blind or your all of your testing, your placebo testing, the whole works, right? And that requires huge resources, which I don't have.
Of course.
So it's is there value in just doing a video laughing at this stuff? Do you think, or should we?
It's a tough one.
Technical.
It's a tough one, because first of all, there's that very famous physicist who said when it's so bad it's not even wrong. It fits in that category.
That sounds like Feynman. That sounds like Feynman.
I forget who said it. I don't know if it was him, but it is true. Sometimes things are so far off from reality that it actually cannot be adequately addressed. It's difficult to address. It's difficult to go after it, because there's nothing that you can latch onto, and then there's no train of thought to correct what's going on. But going back, I watched this documentary, which I highly recommend you watch on Netflix. I think it's called The Curve, or Beyond the Curve, or something. Is about flat earthers.
Oh yes, it's great. Beyond the Curve.
Really,
yes, it is hilarious. I highly recommend it too. Yep.
But if you look, there is one part of it where they have this conference where they are together.
For those that don't know, this is about flat earthers.
So they have this kind of conference where they get together and they present and they talk. But if you listen to it, it's actually more of a community, right? These people want to belong to a group of people.
A group.
Yeah, and they comfort each other and they feel good in each other's presence. And that's the actual thing that's going on there, right? They're not even talking about, they did try to scientifically go after it, which failed. But putting that aside, it's really a sense of belonging. And if you leave an entire group of people behind because you didn't educate them fast enough, you didn't get them to appreciate the science fast enough, and if you ridicule them, I really do think it pushes them further into that fringe.
Into that,
It's even harder. I think it becomes harder to bring them back. But but at the same time, there's no infinite amount of time available, which is why it's so important, especially for some of these technology websites, when they write gibberish and they write things that are not well studied, they don't go after it carefully, they make these big headlines about things just so that they can get the click. These erode the confidence in science. and they erode the effort of the people who have to come after it. So,
yep.
People like yourself, you're doing something that is a huge service to the community in a way, because everybody who comes and sees somebody, and I think you hit a good balance between laughing at it but then explaining it, because if you make a video just laughing at it,
I try and explain it if I can. There's often points where I just can't, so all I can do is laugh at it.
There's things you cannot do, of course. Of course. But I in my 5G video at the end of it, I said something which I genuinely believe in. I showed a picture from when they were burning witches. It was a witch burning kind of photograph, not a real one, obviously, a drawn one of a depiction of what was going on. And then the photo next to it was one of the photos where we launched a satellite, or it was landing on the moon or something like that, one of those photos of something. And I said that, we went from burning witches to burning rocket fuel, to leave our solar system. And this is an extraordinary transformation for a species, right? This is the two ends of as extreme as you can get. And it's the same idea, but if you push it further to a point where the appreciation goes away, and then this love and passion of genuinely understanding and this constant distrust, then of course you're going to fail. And part of the study that I was mentioning, by the way, was about the way the algorithms on YouTube and Facebook and other places work. And I did this experiment a while ago. I haven't done it recently. Maybe somebody can try it. I cleaned up my browser history and everything. So I entered YouTube from a blank slate. So YouTube knew nothing about me. I even did a VPN, so they could know nothing about even my location. And I searched for vegetarianism. Okay, just being a vegetarian. So then obviously there are videos about being a vegetarian. Now you select one video, then you watch it, and when it ends, YouTube gives you recommendations. And then those recommendations are always inherently taking it a step further. So you can latch either on the left or on the right. If you latch on the right side, you keep going, you're going to end up in a video where someone says we should kill anyone who eats meat. And then if you go and if you latch to the other side, you watch video, 10 videos later, you watch someone who's like, we should kill anyone who doesn't eat meat. It's just that YouTube's algorithms, intentionally or not, they want to keep you on. And the only way to keep you on the platform is to show you a more extreme version of whatever it is that you just saw.
I don't think that's deliberate. It pushes you out either
No,
edge.
I don't think it's deliberate.
No, I don't think it's deliberate. It's because those extreme videos are more sensational, so they'll probably get more clicks. So it's a self-fulfilling thing. You're going to end up that way. Yeah, that's interesting if they could tweak the algorithm to bring it back in the middle, but then it becomes a point of you're a publisher now. You're not a neutral platform anymore, So should the most popular videos, regardless of what they are, should the most popular videos rise up? I mean, why not? You could make that argument.
Yeah.
Right.
No, I'm the first person who would fight for people to be able to say whatever they want to say, as long as it doesn't cause harm. It's the openness. That's vital. The other, but going back to the algorithms are self-learning. So it just happens that it's evolved on its own in a way. So the algorithms have figured out through this neural network pattern of detecting that, if I show a more extreme video, or if I show this video after that video, it keeps people on, and it's just cranking forward. It's not like somebody actually programmed this manually. It's not done that way.
No, it's not.
Yeah, it's not like that. But then going back to being a publisher, one of the things these platforms like YouTube and Twitter and Facebook and so on, one of the ways they originally operated was they basically eliminated the thing that editors used to do, because anyone can put on anything they want. And in a way, they kind of cleaned their hands and said, no, we're not publishers, so we're just hosting. So we're not responsible for the content on our site. But then at some point, if everybody gets their news from the same source, should you still say that entity bears no responsibility? And how does that work?
I know.
I don't know the answer.
There is no easy answer. Yeah. It's almost impossible. Another thing that I have to, when I get all these emails, can you debunk this? Can you debunk that? Is I go, one of the reasons is no, I can't for technical reasons. You can't do it. The other one is no, I don't want to give them the oxygen. Like, there's the argument you shouldn't debate the flat earthers because that's what they want. In fact, the wireless energy transfer, the new one I did, the what is it, the Wiggle? The founder of Wiggle actually wants to, he contacted him, wants to come on, wants me to interview him, right? It's like, no, I'm not falling for that trap. That's what, because that will then give them marketing, info, right? It'll give them stuff that then they can market. Look, I was on the EEV log, it's like, no. Is there stuff that you won't touch actually because of that? The audio stuff, like I won't do, people have said, do a audio debunking, a proper technical audio debunking, audio snake oil debunking. And I go, no, I don't want to give them the time of day.
That one, people might actually show up at your door and kill you.
Yeah, right.
That's a serious one. You don't want to go after that one. But I actually got that, there are some things I obviously don't do for many reasons. One is that there's conflicts obviously from where I work. I don't want to jeopardize things. But when I did the teardown of the Starlink dish.
Yes, I remember
saw
that.
And it was a very interesting video. Someone was nice enough to send me the dish, and I really enjoyed working on that. And I got a lot of messages, and one of them was an interesting one. Somebody from, I guess, one of the reporters of BBC contacted me, and they wanted to interview me about the impact of having this kind of thing around the world on oppressive governments and regimes, and how would they react? I'm like, so let me understand. You want an Iranian-born person living in the United States to come and tell you about oppressive regime? I mean, that's clearly not going to happen, right?
Right.
But at the same time, and I understand why they're talking about it, because it's so hard to block it. It's hard to block satellite signals. So if you have one of these satellite dishes, let's say in somewhere where people aren't allowed to have access to the internet, and then you put it on, and you're behind all the firewalls, you have direct access to the same internet that most of the world has. So the impact on information exchange from within oppressive regimes is very strong. It's something that certainly has geopolitical impact. These satellites that Starlink and then Amazon Project Kuiper might be doing. So I think it's a very interesting thing that's going to happen, and I'm always for open information, open access. That's one of the reasons I make the videos, and I make them available for free and everything. It's because I want everyone to have access to knowledge. So, but obviously, I'm not going to go on BBC and tell you that this, and it just doesn't. It's not. It's just a bad idea. So that's why. That's why I decided to not do that. But
there's so many I just won't touch like I want to, because I love doing this sort of stuff. I love reading all the comments on the videos and stuff like I just love doing it. But it's like, no, I'm just going to give them the platform they want. I'm going to give them the oxygen, and they'll take me out of context, guaranteed. Like, is that something that you're actually concerned about, being taken out of context? Because I'm somebody who even though I'm debunking something, I will actually give them a massive benefit of the doubt when I'm doing my whiteboard calculations for solar roadways or whatever it is. I'll go like, even if everything's like, I'll assume everything's perfect, and the numbers I'll run are based on everything's perfect. I won't even take practical things into account. And even then, like they could take that out of context. They could take any aspect of that and snip it. Is that something you're
you're a lot more famous, so you have exposure to a much wider range of people and a much larger number of people. So you run certainly that risk more than I do. I'm probably for every 1,000 people who know you, maybe 10 of them know me. So
but if you do a video, they'll search for it. If they're the owners or whatever, they'll search for it. They'll find it. They'll guarantee they'll find it, and they could snip it. So it doesn't matter how big your channel is, really.
Yeah, this is a problem. I think everybody who puts out their opinions into the open environment, and that's part of the sacrifice I think you have to make, the risk you have to run. And many brave people, much braver than I, have done this in the past. So I think it's a small price, and I don't touch a lot of topics that are very sensitive to begin with. So I'm fairly sheltered. Like I said, the biggest controversy that has come my way was this Starlink dish business. So which again is not even that is not such a big thing. But I mean, if you look at the famous people, even more famous people who speak against injustice, people who speak against problems in different countries, they are constantly under attack and constantly being taken out of context. And they go back and they dig other things that the people have said. And nowadays, you can't even change your mind. Because if let's say you go back as an example, let's say you go back 25 years, okay, and you find that somebody said something 25 years ago, which is considered offensive today.
Oh,
okay?
God, that just bugs me.
So what is the outcome here? If this person no longer believes whatever they said 25 years ago and has changed, I mean, isn't that a sign of growth? Isn't that a good thing? If they're still saying it, then you judge them for today. That's a different story. But if they've moved on and they have made their apology and then they have said, okay, I don't accept this anymore. I don't believe this anymore. Shouldn't that be enough? And what's the controversy?
It should be, but it's unfortunately that's the cancel culture. As somebody who's been cancelled, I know all about that. I won't go into details, but they tried to anyway. But no, it's easy when it's hard when you work for yourself.
That's it. Exactly.
They will go after your livelihood. And that's the culture these days, and it's awful. It's awful.
Yeah, that's a whole other problem at the same time. So fighting this multidimensional problem from all angles at the same time. But at the same time, I think that there's some extraordinary things that happen constantly in the field of science, and you look at it, and it's really truly inspiring. I was listening to this doctor talk about just the development of vaccines in general and how hard it is and how difficult it is. And I think he said that on average, it takes 8 years to develop a vaccine.
Oh yeah,
So
that's
they did this in in less than a year, right? And to be fair, there are some having such a large sample.
The actual technology, the mRNA technology, was already in place before this whole thing happened. They just used it. They just hadn't used it before because it had take so long. And then, but now they had a reason to use it. And
and then they put almost an infinite amount of money into it, and then you also had a large patient sample, which doesn't typically happen.
Exactly. That's one of the main things.
So it's amazing. I mean, again, proud to be a human, honestly, looking at some of these things, and I wish that people could again share the passion for it. It doesn't mean to be naive, of course. There's a big difference between being naive and appreciating the positive. And I said also in a different video one time, I said that knowledge is basically, information is free. Knowledge is free. It's not the most important thing. And I think people misunderstood. I said that knowledge is not the thing. The faculty of discernment is the thing, right? But it's not that knowledge is not useless, obviously. You need to have it to do anything. But what I meant was that you can get anything you want. You have the entire human knowledge in your fingertip. But what part of it is useful? What is real and what isn't? That skill to differentiate those two, you need that now, whether you like it or not. Because whether you like it or not, if you're looking for a new piece of information that you don't know, you're going to run across several contradicting things. You're going to run across several pieces of incorrect information embedded among everything else. And you need to figure out what is right and what is not. That's a skill they need to teach, I think, more and more in schools when people are young, and figure out how to do this.
How do you teach that? I've always, that's always been on the tip of my mind, is like a video on how to think critically, how to research stuff, maybe, but I've never sort of thought of a good way to do it.
It's a tough one. I think I have 3 rules for it generally. Is that first is that you look at if a person who is trying to give you a piece of information in a certain way, if they have a vested interest in that information being
number one, that's warning sign number one.
It doesn't mean that it's wrong. It doesn't mean that, right? But it is something to take into account. The second is that you look at the source. Where is the sources of information? Is it somebody reporting it from someone else who reported it, from someone else who reported it? You find and again, these things all take time. That's the problem.
Exactly.
You find out where it is coming from. Is it gone through peer review? Is it gone through third-party independent study? Is it something that is consistent with other pieces of information that are established and so on? And you go through that one. And the final one is you look at yourself. Do you have a vested interest of accepting one version of it over another version?
That's right.
So that you can at least address your own sense of bias and delusion on the topic. Those are kind of my 3 tests that I try to run on a piece of information. But unfortunately, these all take time.
Yes,
and that's the problem with
and
misinformation.
most people just don't want to put in the effort. And that personal vested interest doesn't have to be financial. It could be, oh, this makes me feel better, or this makes me look smarter.
Yeah.
I can virtue signal about this to my friends. That increases my social, credit, whatever. People
I'm
do
just
by
afraid of
virtue
it.
signaling these days, or just afraid, or fear, or anything. It's. I'm sure you could come up with a list of dozens of different reasons why people could have a vested interest in actually believing something.
Yeah.
And how do you separate the technical ones from the feel-good ones, though? The ones that, but it all comes down to, well, what's the cost if they believe something? It could actually, as you say, cancer treatment, they'll die, right?
Yeah, of course. No, those are obviously always going to be the case. That there's a clear answer to that. If you're taking a medication that you think is curing your cancer, but you should be getting chemotherapy, then obviously that's clear. But you wear a crystal, you feel good. Let's say somebody gives you a crystal that makes you be happier. You may even be happier. But to me, those who offer you false constellations or false friends, I would rather have the actual piece of information, the truth about something. And again, we all have a certain level of delusion we cannot escape as human beings. It's just the nature. But fighting it in a constructive way, I would say on average, having the right piece of information on average is always better, even if it doesn't help you feel good at the moment.
What about the credibility of sources? Because obviously in the current climate, which we won't get into, there have been things that have been proven to be wrong. For example, this is not just in the medical field, but this is in the political field and all sorts of fields that, people like this was, this was proven, a year ago or 2 years, 5 years ago or something. And now it's like, no, that was all BS, And it was and then that ruins the credibility. And if that happens to, say, an organization, be it a news organization, or it happens to a medical organization, or it happens to a political organization, or whatever it is, if it happens so many times, that erodes public confidence in that. They don't. Can you actually blame people for not actually believing that person or that source or that government anymore because they've lied to them, so many times?
Yeah. This is what I was saying a little bit earlier too. Is that whenever a conspiracy theory is true, it feeds onto the next one. So let's say you have 100 things. You just need them just enough frequency to keep the thing going. But going back to what you said about you're always going to find some doctor or someone with a PhD or someone who's going to tell you something that's wrong, right? I mean, humans are not infallible.
Exactly.
Having a PhD,
the system and the system of peer review. People hold up peer review as the holy standard. No, there's countless examples of a peer-reviewed paper being completely and utterly wrong.
Yeah.
So,
but people have to also keep in mind that every time that something was wrong, that's actually testament to the fact that the mechanism works.
That's process why works. That's right.
That's why
process.
Why the reason you can point to it is because the system on average has an upward progression, right? Yep. I mean, again, the fact that you have this cell phone in your pocket is a proof of that. The fact that you can be picked up tomorrow in a helicopter and get an open heart surgery.
Yeah,
that's proof that these things work, right?
Exactly.
So, but yes, of course, things can be wrong. Scientists can be corrupt. Institutions can be corrupt. Yes, but that's why we have genuine, honest scientists that fight for these things, and that's why there's this upward progression all the time. But that not every mistake is going to render the entire thing pointless. That's part of this discovery.
Yes. The system's going to go on. The scientific process is going to go on because it's the only well, it's not the only way, but it's the best way we have. It's the best tool we have of actually progressing in science and engineering and everything else. So
no, absolutely.
It's just nuts. Are there any other ones you've seen lately, dodgy products that you're not like? I always keep it made the rounds again because people are seeing it on Facebook. It's the energy saver thing,
The battery
It's
one?
a capacitor in a box. No,
Oh, yeah.
it's just a capacitor in a box. And just the marketing, every couple of years, the marketing just comes back and back. And I get a flood of emails that my mum saw this on Facebook. You know, is it any good? And it's oh.
But I think just for the viewers who may not be familiar with it, it's the idea that, so what happens is in your house, you have a lot of different kinds of loads that you put on the power line. And it turns out that there are quite a few inductive loads. And these inductive loads can be motors and power supplies and big transformers that are on different things you have. And these things cause a particular current voltage ratio that you would draw from the wall. But in most places, at least in most residential places, you don't pay for
it, exactly.
Apparent power, right? You don't pay for it.
You don't pay for it,
because it just, all it means is that every time you have this kind of up and down waveform of the current, you pull a lot of current from the grid, but then on the next cycle of the power, you push it back into the grid. That's what a reactive load would be. These capacitors in a box, putting it onto your power line shows up in parallel with all the other inductive loads in your house. And that they tend to cancel each other out, and they bring the phase of the power voltage in phase. So you look more like a resistive load. Now, the difference is this makes no difference in your power consumption because you don't pay for apparent power. You pay for real power. In some industrial scenarios, you do, because the current being very high, being pushed in and out, actually causes you to need bigger copper wires. So they can handle that extra current. So then that means the cost of the grid is a little bit higher to deploy for some.
That's the argument.
Yes, but it doesn't apply.
I put in one of my debunking videos.
Yeah, but it doesn't apply
to the
your
residential.
Home. Yeah, to your home, it doesn't matter. And these people are just stealing your money.
But being the engineer that I am, I had to explain to them that yes, in theory, you are paying more because, as you said, more copper on the actual grid infrastructure. That means you're paying in increased bills for that infrastructure. So in theory, you are paying more because of this apparent power, but it's not because of the metering in your box. So actually just putting the capacitor on there won't do anything. But it's based on a real thing, right? Power factor and apparent power is a real thing. But it's like, but I thought that was a slam dunk video I did for that one, debunking that. And I've done it twice actually, I think, but it just keeps coming up, and it's just like, I can't keep making the same video over and over because it's got a new branding on the box or whatever, you know, it's just.
And my favorite one on Amazon are these metal cages you can buy and put your router inside of it to protect you from your. I'm like, I can tell you it works. It will block but it will also block your Wi-Fi. I mean, you won't have Wi-Fi. If you don't want to have Wi-Fi, just unplug it. You know, it's the same thing. You don't need to have it. And
or you can go into the Wi-Fi settings and adjust the power level if you're worried about it.
Yeah, just lower the power, and that's exactly the same thing. You're reducing the range, and that's fine. If you're more comfortable with that, do that. But don't pay. Because these things are like $70. Like $70. It's a mesh box. You can make it for $3 if you really want to. But it's a frustrating. It's frustrating because so much money is being, and the thing is that again, these things happen and people buy them, and this causes mistrust of other future things too. Because the person who goes and buys this box and puts it on the router, and all of a sudden feels smarter. They feel like, oh, look at me, I didn't let the man come and put EM into my home, and next time it's something else. You just make yourself vulnerable to future problems and future things that may come your way.
Yep. So should I be doing a video for every single thing people send me, or is it just like my limit is, well, you know, I don't want to give them the advertising, like unless they've raised like $1 million on Kickstarter or something. I'm like, if it's raised, $100 or whatever, like I'm not gonna, like, it's just gonna die a certain death, right? There's just no point actually advertising it. I
mean, for you, given that at least this whole YouTube thing is your main profession. I know you also make a lot of products. It's a very different story. So you do 100 different things at the same time. But I would say that maybe tackling things that have direct human life on them in a very clear way is probably the one that makes sense. Like there's solar roadways. the money in that can go for something much more valuable, especially when the government puts taxpayer money onto it. I mean, that's a clear one in my view that it requires to be addressed. Yeah.
I'm glad I actually did so many videos on that because it keeps coming. They just raised another $2.5 million solar freaking roadways. And they're just installing they're installing new ones in the Netherlands. They're installing the solar bike paths again. They just keep on doing it. And it's like, wow, it's just unbelievable. Like, I don't. Then the other level is the politicians. They're the ones that are actually, how do you target the politicians? Because they're the ones who have the financial purse strings, right? They can put government money behind stuff like this.
This was the point that I also wanted to mention. The issue with politicians is that that's why it's really important to make sure the public is well educated, because if you have a well educated public, the politicians will not be swayed to do something to appeal to an ignorant population,
right?
Whether they believe it or not, right? I mean, the politicians may have they may even know the right answer, but if they want to have the voters, if you want to have, then you have to go with what people believe in. If sufficient, I am sure if sufficient number of people believe the Earth was flat, there would be a politician the other day who was like, I'm going to remove round Earth from the school systems.
Exactly.
It's just a matter of time, right? So it's not that far-fetched. So that's why the public needs to be very well educated, so that not only can they not be taken advantage of by the people who are purposely trying to fool them, but also to not allow politicians to potentially, just to get the votes, pass laws and regulations and do things that are just harmful or ineffective. And that's another reason why I think it's so important for the public to be aware and educated and scientific thinking and critically thinking.
The problem is that there's so few people willing to put the effort, because it takes effort, as you said. It takes order of magnitude more effort to debunk something than it does to actually believe it in the first place. And there's so few people willing to put in the effort because there's no. I guess once again, there's no financial advantage to it. Like, my videos do well, but it's not like I'm going to get rich from just starting up a debunking channel or something like that. So, how do we get more people involved in? Is there any way to do it, or are we just doomed to that only X number of people like us are going to be, willing enough to put in the effort? Think it's important enough?
I think these conversations help, and I have received a lot of emails, a lot of nice, wonderful messages from people who watch the videos, and they said that they're inspired to either go into a particular field or to make their own videos, or to make sure that they speak to other people about whatever their field of expertise is, to make sure the misinformation doesn't propagate, and that these things, that the correct message, that the right thing and the right sources of information are preserved, and that the right things are passed forward among as many people as possible. And that's why we said that everybody in a certain field, once you're an expert, you are an ambassador of your domain of expertise, in more than just working in it, but also making people understand it. That's why people like Carl Sagan and Tyson and others, people who do popular science, and I've spoken at Brian Greene, and there are many of them that I can mention. These people are much more than just their being physicists or scientists and so on. They're also doing whole other layer of benefit to humanity, and is to making very complicated things understandable.
And ironically, those people have reach because of their apparent authority. So I know there shouldn't be an appeal in an ideal world. There shouldn't be this appeal to authority. Everyone should look at the data, should have the critical thinking skills to look at the data and decide, oh yeah, that's obviously BS. Right. But unfortunately, the majority of the population, you have to appeal to authority almost, don't you? I mean, it's just
you have to look at the reputation. You look at the reputation and see, where they've published, how they've published, and where they stand on something, and whether, again, there's a conflict of interest for them or not. And these things do help if you follow those trails, and you can see where it takes you. And at the same time, when people who actually have some expertise in the field are the most dangerous when they go bad. Okay.
Yes,
just
exactly.
think about for a second. Yeah. Let's say if you wanted to sell some dodgy product, I mean, you could put the right language on it. You could say the right things. You could say just the right amount of technical, and be articulate about it. So when experts go bad, they go bad indeed. That's why that's why the scientists, for example, who either have lied or have presented things that have later on been proven to be incorrect are so dangerous and so harmful. And that they are by far the most dangerous. And the person, I forget his name now, the guy who originally faked the result of the vaccination autism link. He lied.
Oh, the autism link
lost,
thing. Yeah, I can't remember his name.
He's lost his medical license, right?
Yes,
but
exactly.
But the damage is done, right?
Exactly. And they still citing that.
It's
people
crazy.
Are still citing that today. It's, as you said, the damage is done. And I've seen this with my April Fool's jokes, which I don't do, but a certain video comes out on April 1st, and tens of thousands of people will actually believe what I've said. And it's like, it's, like it doesn't do any harm, right?
Sure.
But it's just for fun. But it's amazing what people will believe because I said it. It's like, exactly. Scary. So, oh boy, yes, we've got a lot of responsibility, Shahriar, on our shoulders.
And it's not a bad thing. Not a bad thing.
It's not. No, it's good. But somebody's got to do it. Somebody's got to do it. So I'm glad that there's an increasing number of people willing to do it when they see other people willing to put in the effort to do this. I think that's important because they might go, oh yeah, I can. It doesn't have to be a video. It can just be a blog post somewhere. If you just go through the calculations and here it is. That is worthwhile.
Yeah, and one of the things I think I try to tell also engineers is to focus and learn how to be concise and articulate on the messages you want to convey. Because engineers tend to because we're very technical, we tend to dive in and say too many things. And you have to know your audience. And that's whenever somebody asks me to present something somewhere, then one of the very first thing I ask is tell me exactly what the audience composition is.
Yes.
Who's going to be there? What's their background? Where they're from? Why are they there? So that I can adjust not just the tone, but the content and the way that you describe it. One of the things that is also really frustrating with YouTube videos on a separate note is when things are verbose. It drives me crazy.
Oh, yes. Yeah. I can't help it. Like, it's just my nature. I mean, it's just, yeah.
You're not verbose. Believe me, you're not verbose. And but there are some that are just so, and that's a problem because then that they're losing the opportunity to have exactly the impact they're looking for. And they're very knowledgeable. They're fantastic. And I just trimming it down it helps a lot.
You talked about Neil deGrasse Tyson before, who's a science popularizer, and he said, yes, the best skill I learnt was, because he always, anything happens in any realm of science or anything, he's one of the first people that the media call to, it's UFOs, are they real? And then they'll get him on because he's the science expert or whatever, or they'll get Bill Nye the Science Guy. And anyway, he said that the most important skill he learned is the soundbite because that's all they're after. The media are after that 10-second soundbite so that they can put that on the 6 o'clock news and that draws people in, and that's all they want. That's all they're after. You have to concise it down to like 10-second soundbite, or as I said, like a 10-second, like a 1 minute video that goes viral on TikTok or whatever. Like, unfortunately, that's how far you have to dumb it down.
Yeah, it also helps that he's very articulate and very eloquent, and he can put things in concise terms. So that's a skill that he has for sure. And make sure that you teach children the skill required to differentiate what is true and what is not to the best of their abilities, and putting the effort and fight against misinformation, fight against injustice as much as you can anywhere in the world for any topic.
Yep. Is there an age, do you think, that you should be teaching kids? Have you seen any data on that or whatever?
Well, I'm not a parent yet, but maybe I'll get that. I'll get that experience myself.
I could guess it's like it's probably like 7 or 8 when they start developing the critical thinking skills. Perhaps I could be way off, but
but
I've only got a sample size of 1.
Sure.
At that age.
The thing is that for you, I mean, obviously, as a parent, that's one of the reasons I think honesty is so important to kids. Okay, because I listened to this book called Lying by Sam Harris. It's like only an hour and a half. I highly recommend it. You listen to it, or read it yourself. So he says, he basically, he goes all out. He says, honesty, 100%, no white lies, no nothing. And it's worth listening to his reasoning.
Yep.
And he says that to his kids from the very, very beginning of their life. They didn't tell him about Santa Claus, didn't tell him any of this stuff.
Right.
He was very honest, because he said that if you show that honesty, there is never any doubt in your kid's mind at any age that you have the ability to completely lie to them and fool them. I know there are practical limitations to that, and I'm not a parent, so I'm just guessing. But but to you can teach that, I would imagine, from very early on to evaluate what can or cannot be true, to follow a train of thought, and you make it more and more advanced as time passes. And of course, once you get to the age of 7, 10, so on, then more and more critical thinking should be taught in schools. Just like, finance should be taught in schools. Like no kid should come out of high school and not understand how to do finance, right? So it's the same thing.
Yep, I totally agree. Yep. Although I don't necessarily 100% agree with Sam Harris there. It's important to have that imagination to believe that Santa Claus is real. Like there's a whole psychology and brain development thing behind that. So I'm not sure, but I certainly the concept, yes. I understand where he's coming from. Yep.
Totally. We can talk about that.
I totally agree that that's important.
We can talk about that again. It's his view, and it's worth listening to. But indeed, it's the idea of honesty.
The concept
is for that. The concept of it. Yeah, of course.
I totally agree. Yep. And there's a lot of people who say I shouldn't do my April Fool's videos because of that. People won't know whether I'm lying or telling the truth. It's like, well, come on, come on, the video, like it's obvious, right?
I mean, I made only one actually, but I made mine so ridiculously clearly, insanely obviously that it was not true. But you're really good at it. That's the problem. I mean, I fell for the fluke one you made.
Oh, the fluke one, yes.
I genuinely thought that was true.
that was a fluke.
So it works.
Yep. And I do it because I just find it fun.
No, it's fun.
Troll
it's
people. And that's why I never tell people about it. Like I never go, April Fool's at the end of it. I just let them believe it, and then figure it out for themselves. Because I think that, there's a skill in that as well.
Yeah.
It's like, like they're going in the back of the mind, was that right? Can I really etch a PC? Can I etch copper on a PCB with plain tap water and a magnet? Like, it's and they think about it. And then I've had actually a lot of people say that I've gone away and thought about it, and I came to the conclusion it was BS. And then and then I checked the comments, and sure enough, I've been had, and I think that's valuable. That people learn that. So
sure, and you're not trying to sell anything, and you're not touching a topic that is important for people's lives. So it's good.
It's all good. All right. Well, thank you very much for joining us again.
Of course,
Shahriar.
Of course, it was a pleasure, and hopefully we do this again in the future.
We certainly will. Thanks, mate. Catch you next time.
Absolutely.